Good morning, ladies and gentlemen. Welcome to Global Compliance Panel's live webinar on cleaning and sanitation training for food processors. My name is Michael, and I'll be your host for today's session. On behalf of the Global Compliance Panel team, I'd like to thank you all for being part of today's event. Today's webinar is being presented by Melinda Allen. Ms. Allen is a food safety and quality consultant in the food industry. Melinda's had a long and dedicated career of quality assurance and food safety leadership with companies such as Yum Brands and Quiznos. Her consulting clients have included leaders in the field such as Burger King, Panda Express, and Popeye's Louisiana Kitchen. She continues to work with many of these and additional clients. Melinda and her team of experienced professionals are available for quality assurance and food service auditing, specification and program development and training, and also product commercialization. We are honored to have Melinda Allen with us to present today's session. Ladies and gentlemen, before we begin, I just want to quickly outline the program for today's session. This webinar is for a 60-minute duration. First, Melinda will take you through today's webinar, highlighting the areas that she would cover, and then share with you her presentation. Also, I want to inform all our participants that once part of the teleconference, you've been placed on mute and will remain so until the Q&A begins towards the end of the webinar. This is again just to ensure there is no discontinuity while the speaker presents the webinar, and also just to ensure that all of you are able to take maximum benefit from today's session. Also request you all to hold your questions back. We do have over 10 minutes of time at the end of the session for your questions to be answered. And for any reason, ladies and gentlemen, if you do get logged out of the session, please make sure you could join in the same. And also, ladies and gentlemen, and now I do request Melinda to take it from here. Melinda?
Hello. Thank you very much for that introduction, Michael. And I want to welcome everyone and thank you for attending the presentation today. I know that you will benefit from information presented, which I've gathered and learned over the course of my auditing career. I find training for cleaning and sanitation to be very beneficial for teams in order not only for food safety, but also to maintain their facility and resources or assets. So without further ado, let me proceed on to the agenda and what we will be covering today. We'll talk about the scope of sanitation and cleaning, meaning what areas should be covered by this program. And then we will differentiate and talk about each of the two different types of processes, both sanitation of food contact surfaces and cleaning of the remainder of the facility. We will also spend some time talking about chemical safety, which is very important not only to the safety of the food, but also to the safety of yourselves and your team as operators within the sanitation program. Then we'll have a brief review and closing. And I've also included a knowledge assessment or a quiz so that you can either take that for yourselves or share that with your team members to make sure that they grasp the fundamental and important concepts that we've covered today. And there's also another just helpful form, which is an attendance acknowledgement for you to file with your documentation that you have received this training. So next, we will proceed on to our introduction. Our purpose, again, here is to familiarize the team with the principles of cleaning versus sanitation, so we will understand when those two terms should be used. A lot of times they're used interchangeably in the industry, and they shouldn't be because they're two totally separate things. And then we will talk about, as I mentioned, chemical safety, so we'll get into not only the chemical properties, but also their safety and effective use and how they should be stored. Starting with some just terms that will get us into our subject matter. The three key terms that I want to define here are sterilize, disinfect, and sanitize. These terms should not be confused. As you know, the title of the presentation is Sanitation, and so we will be focused on sanitizing. Sterilizing is the destruction and removal of all living organisms. That's what happens in the pharmaceutical industry, not what happens in the food industry. As you know, there are a lot of microorganisms that are of no concern in the food industry because they may also even be a part of the food process. They may be helpful to the microflora and our digestive system, and they're ubiquitous, so there's not a way to preserve the food and then eliminate all microorganisms. So we're not sterilizing. Disinfection is destruction of all vegetative spores. So this is what we would do on contact surfaces in our homes and also in employee areas within the plant. So here we're looking at keeping the microorganisms down to a manageable level, reducing any microorganisms in general. Again, we're not differentiating between types of microorganisms. We want to kill anything that could grow and lead to a potentially dangerous situation in terms of health or sanitation and cleanliness. What we will be discussing is ways to sanitize. This is the reduction of microorganisms to levels considered safe from a public health viewpoint. So the one situation is reducing the contamination level a 99.999% or 5 logs in 30 seconds. And then on non-product contact surfaces, we would want to reduce by 3 logs or 99.9%. Again, what we're looking to do with sanitation is to reduce microorganisms, not totally eliminate. That's not necessary, and it's actually not even helpful because most of the microorganisms that exist in the environment, as you know, are non-harmful and actually outcompete the harmful bacteria. So we want to keep some of those bacteria in the environment to outcompete and to prevent explosive growth of pathogens or potentially dangerous microorganisms, those that are involved in foodborne illnesses. So now that we've defined sanitizing and sanitation, let's talk about that versus cleaning. Cleaning is closer to disinfecting, wherein what we're trying to do is on a food contact surface, we want to free it of bacteria that might contaminate products and ingredients, causing foodborne illness. But those areas that are just near the food contact structures, we want to also sanitize and clean so that they're not a source of contamination. But non-food contact surfaces just need to be clean and free of buildup. So we don't want to have a biofilm or a layer of protein or starchy material that would harbor or cover bacteria such that when we go to clean, we can't actually reach them with our chemicals or water. Or, hello? Or we want to prevent any incidental contamination. And again, so what areas do we want to sanitize? Let's list them. They're going to be our food contact surfaces, like processing equipment that has direct contact with food, our tools, anything we're using like spatulas, scrapers, tongs, anything that moves the food or it comes in contact with the product needs to be sanitized. Near food contact surfaces, very important. Support equipment, nearby structures or shields. Say, for instance, if you have a Lexan viewing screen, overhead structures, refrigeration units. Say, for instance, if it's a spiral freezer or a refrigeration unit that's bringing down product temperatures, it's a cooling tunnel. All of this, including the HVAC systems, or refrigeration systems that support it, and forced air used to convey product or used to blow off excess water. All of this needs to be sanitized because it does, in fact, come in contact with the food either directly or indirectly, as in the employees who are working with the food come in contact with these structures. Say, for instance, you have inspectors on the line and they are pulling out defects of pieces of shrimp. They will touch these supporting structures and then touch the product. So through that chain of contact, you have the potential of contaminating product as it's moving through the process. That's why it's important that we also include near food contact surfaces in our sanitation program. Another vector would be condensation, or the steam that builds up during a heating or hot process. That's why it's important that we sanitize any air handling systems that are directly involved in product cooling. Now, cleaning, on the other hand, is what we want to do with non-food contact surfaces, things where we have a reasonable level of control that neither employees who haven't cleaned or sanitized their hands and the product itself will not come in contact with. Walls, ceilings, drains, floors, racks, and cleaning equipment should never be in contact with food, so all we need to do with these items is to clean them. Any food that does come in contact conversely with these systems or with these items needs to be discarded because, again, we haven't sanitized them, we've only cleaned them. Additional areas where we're going to perform cleaning would be the break rooms, locker areas, office areas, and restrooms. Again, these are totally non-food contact areas, areas where employees, after going to these places, should wash, sanitize their hands, and perform whatever types of protective clothing changes need to happen in order to ensure that they're not bringing contaminants back into the food contact area. So two-pronged there. Not only do we want to clean these areas, don't need to sanitize these areas, we also want to make sure that our program recognizes that these areas are cleaned and not sanitized, and therefore when we transverse between each of these areas back to the processing area, that we take protective measures to make sure we sanitize ourselves where we're going to be in contact with food, wearing gloves, washing hands, using sanitizer or hand dips. Not only that, but foot dips, because as we walk through the facility, we don't want to bring any extra bacteria into the processing area that could potentially be splashed onto support structures. So now that we know the difference between sanitation and cleaning, let's talk about why we do these things in more detail. The 9th CFR number 416.1 of the general rules requires that we have sanitary operations. All food contact surfaces, including food contact surfaces of utensils and equipment, must be cleaned and sanitized as frequently as necessary to prevent the creation of unsanitary conditions and the adulteration of product. Purposely, this is very broad in general. What is intended by the Code of Federal Regulations, or CFR, is that each facility or operation take responsibility for keeping their product safe. So all food contact surfaces is the statement here, as well as preventing the creation of unsanitary conditions. So here you notice it hasn't mentioned that anything has been contaminated. It just says that the condition for an insanitary environment should not even be created. So here there's a very broad regulation to make sure that this facility itself is taking ownership of maintaining proper conditions. What are we talking about in terms of food contact surfaces? Let's review. We're talking hand sinks, pans, utensils and tools, so scoops, spatulas, anything used to move products around within the process, also equipment. You'll see here in the picture that we even have forklifts and bags of product. Keep those things in mind too as you're working and looking at your sanitation program, that anything that comes in contact with food or the people that come in contact with food, there needs to be a program or a plan in place in order to prevent that cross-contamination. In this particular environment or example, separating the people who deliver the product to the mixing area or deliver the product to the processing area from the people who actually handle the product is the best practice. I also recommend that pallets, as you can see in this picture, there is actually a wooden pallet being delivered to the deck where product is going to be mixed. That's definitely not a best practice because those pallets have traveled, as you know, through many different environments. And unless they're dedicated just to product which is brought to this mezzanine or brought to this mixing area, they have been in contact with animals and pests and dirt and different transport equipment, as well as people who are not food handlers. So there's a lot of potential for contamination involved with pallets and shrink wrap and overwrap that's being delivered to this mixing area, as well as the hand jacks themselves are being handled by warehouse employees who are not direct food contact handlers. So take a look at your environment and notice where you have that potential for things that have not been sanitized to enter into a exposed food area. Dripping bags, emptying product directly into the mixer is a best practice for eliminating some of that potential, but again, not bringing things that are also used in non-food contact areas into the food contact area is something that we want to control in our program and procedures. Going back to food contact surface cleaning, sanitation, we talked about the Code of Federal Regulations and its definition of the program needing to have sanitation occur as frequently as necessary. A good rule is every 4 hours because we know that the bacterial life cycle is 4 hours. And if we are able to clean, say, mid-shift, end of shift, routinely, then we know that we have a good program in place that would be defensible in any situation to combat bacterial growth. If you're working with non-potentially hazardous foods, dry goods, or acidified foods, or things that are shelf-stable, then it's not as critical. But anytime you're working with meats and produce and potentially hazardous foods, it's really important that there be mid-shift cleanups where we are able to remove product that has accumulated during the processing so that it's not growing and harboring bacteria and imparting that onto the surfaces of the equipment itself. Another tactic to use is maintaining the room temperature below 40 degrees. This is often used in the protein meat industry as a control so that any time that there is product exposed or product stored, the room temperature is maintained at a refrigerated temperature so that any product which is in that area will continue to be maintained at less than 40 degrees or below the bacterial growth threshold. So those two things are what we want to take from here. Every 4 hours, if room temperature is not less than 40 degrees. or if it is greater than 40 degrees. I think I said that right. Another sanitation program frequency that we want to discuss is when there's sanitation occurring less than daily. So most operations produce on 1 or 2 shifts and then clean up or do sanitation on the 3rd shift. However, there are operations which for whatever reason, be it economical or be it setup time or run time or even process requirements, say for instance, deli loaves that are oven baked, that the facility and the process itself takes longer than 24 hours. So in this case, there needs to be a comprehensive study documenting that the sanitation program as defined is adequate with a less than daily cleanup. So say, for instance, you're making soft packets and they are being, and the machinery is running for 3 or 4 days. At the end of that 3rd day or whenever sanitation is scheduled to start up, it's advisable to do a swab prior to cleanup to make sure that bacteria haven't grown within that 3 days to levels that are unsafe, and to ensure that the cleaning program can still reduce microorganisms to a sanitary level with that amount of buildup that occurs during that production time period. This needs to be documented as an official study, written up and available for anyone auditing the plant to justify the less than daily schedule. So speaking of our sanitation program, let's just review that it's going to start with the self-inspection, wherein we just identify what all our structures are, what our products are, and what processes we currently have in place. We'll do an equipment inventory, what areas need to be cleaned, create a facility map of what the various areas are, and then go out and observe what we currently have going on in terms of sanitation and cleaning. From that observation, we would draft or revise procedures, making a detailed account of what each area needs and is what's being performed, and add to that our chemical inventory so that we know what products, what chemical products are being used for which cleaning procedures. And then we'll do a team training like we're doing today, but specific to our own facility. And then this is an ongoing process which needs to be re-verified, say every 6 months, but no less than every year, or whenever there's changes made to either the products being run or the processes or equipment, even the structure of the facility. So whenever there's changes made, we need to update the program and make sure that it's still effective and accurate. If the equipment moves closer together, we may have to change procedures. If we bring in new ingredients that add some type of a different risk level to the processing environment, we need to change procedures. And also if we have new construction in the building and add new areas with different equipment again and products, we need to change the procedures. So this is a continuous process that we should at least update annually, because even cleaning chemicals can change. And whenever you're being audited, you want to make sure that everything is up to date to the current processes so that it doesn't look like the procedures and written documentation are not just books on a shelf. They need to be active, living documents that you're actually using. And the easiest way to know that that's not the case is when they're outdated and inaccurate. And what would that documentation look like? Here is an example. We always want to use document control and demonstrate that by our header tables that kind of give an overview of what's involved in the plan. So we're going to define the area being addressed. We're going to have a checklist of each task being completed. We want to make sure we include accountability and include a step for verification. So someone who is a supervisor is going to sign off that not only has the documentation been completed accurately, but the procedures have been effectively completed. Within those procedures, sanitation is always going to have the same 5 steps. You're going to remove any debris, product residue, anything, equipment that is loose or portable. You're going to apply cleaning chemicals, scrub surfaces so that, again, we remove any biofilms or hang up areas where there is residual product. We're going to rinse away both the cleaning chemical and any of the loosened materials, and then finally apply our sanitizer. Keeping in mind that after the sanitizer, there is no rinse step. We want the sanitizer to remain on the equipment to continue the bacterial kill. And we will talk as we go through about how we prevent any chemical contamination with that as our process. Why don't we want to rinse the sanitizer away? Because remember, our water supply, while it is potable or safe for eating, it is not sanitized. Our water supply is not free of bacteria. And if you rinse away your sanitizer, you're removing your protective chemical and possibly introducing other bacteria. So this is just walking us through the process. Again, this is more important than most of what we'll talk about, just making sure that we get all these steps included and in the proper order and done in detail and effectively. So removing any debris, because again, we can't clean if we have residual biofilms and debris or product residues. Applying the cleaning chemicals, and as you can see, plastic covers over, of course, our control panels or any exposed electrical equipment. And you also see how the support structures, such as the stairway, the stands that the mixers are sitting on, everything is receiving cleaning chemical. We start from the top. We apply in a downward motion so that any debris or everything that we're trying to eliminate is moving towards the floor. And then we start with our scrubbing. So now we want to make sure that the cleaning chemicals are in contact with all the surfaces and that our, again, residues are being removed. Just spraying on the cleaning chemicals are not necessarily going to allow us to remove the buildups that have accumulated during the processing. And we'll talk more in detail about what types of ingredients are more stubborn and require more of this scrubbing. Then we have our rinse step, same as our application of cleaning chemicals. We're going to start from the top and move our way down so that everything moves towards the floors and drains. And finally, we apply the sanitizer to clean and rinse surfaces. Always remember that you cannot sanitize a dirty surface because there will be a biofilm that will trap bacteria underneath, wherein the sanitizer won't actually be able to contact the surface of the equipment. And bacteria will continue to grow underneath that biofilm until it is exposed again to the product contact surface. Now let's focus on cleaning. So we've got all the equipment, food contact surfaces sanitized, but we also have all those peripheral structures that we talked about earlier. Now this type of cleaning we would want to do before we sanitize, but typically needs to happen less often than sanitation. Sanitation is going to happen every time we run products, again, because this is most critical and it is the law. Cleaning all the other non-contact surfaces, usually there's less, we're not having products contact these surfaces, so it's less likely that they're going to get built up in dirt. So what areas are we talking about? We're talking about the ceilings and lights. We want them to be clean and in good repair and free of cobwebs, leaks, and stains. So there is a component here for maintenance as well as sanitation as well as operations. So starting from the top of the facility, we need to have a frequency that maintains, and keep this in mind, when you're going through your regulatory audits as well as customer and third party and GFSI or global audits, it is the responsibility of the facility to have a frequency set up that maintains the facility in a clean manner. So just having an annual cleaning of lights and ceilings, et cetera, really isn't the intent of the standards. It's that the item is maintained clean. So that frequency needs to be increased or made more frequent if buildup is occurring on a more frequent basis than is scheduled, than the cleaning is scheduled. So we're looking at making sure overhead pipes are clean and free of cobwebs, leaks, and condensation, all for the obvious reasons. Cobwebs would indicate insect activity. Spiders are getting in through holes. Spiders are attracted to other insects and food debris that's left in the area. So if we're free of cobwebs, then we know that we have our insect or pest activity under control. In good repair, because it's difficult to clean and sanitize or clean any areas where there is breach in the material that allows bacteria to be trapped inside. It's also an access point for insects or even rodents. Leaks and stains, of course, that is a potential contaminant from non-potable water or even water that has been contaminated and hung up in the system. So we're always on the watch out for these types of potential sources of contamination, and they need to be a real critical part of our cleaning program. Then moving to the floors, the same, they should be clean and good repair, also free of debris and buildup. And drains being free-flowing and free of debris and odors. Working backwards there, the odor is the indicator that we have some bacterial spoilage going on and that there is debris building up in the drains and that they're clogged in some way, that the debris is not flowing out towards our waste management. That also prevents us from keeping our floors free of buildup and debris, which a regular program of sweeping, squeegee, et cetera, needs to be employed, even during production, because we don't want to wait, especially if you're running 2 shifts, you don't want to wait until 16 hours later. Again, that's a lot of time for bacteria to build up as well as food debris, such that it makes the cleaning job a lot more difficult. which brings me to a really good segue that we want to always be sure that the program is at its optimum for the team to execute the procedures. So, for instance, we all know that anything in life, if it's difficult to do, it's not going to be done properly. We want to make it as easy for the team as possible. So oftentimes that means doing it more frequently so that it's an easier, smaller job than, again, waiting to the end when it becomes just, overwhelming for the team member or beyond the scope of the time period that they have allotted to doing that task. And finally, floors being in good repair, same reason as for the ceilings. Anytime you have crevices, cracks, and divots in the material, makes a good harborage point for the bacteria and makes a lot more uneven surface for our cleaning chemicals to act on, and you'll see what I mean as we go into the cleaning chemical effectiveness portion of the presentation. Let's not forget our production and storage areas, that we want to include the walls. Walls tend to get a lot of contact and buildup, not only from our hands and the product that incidentally contacts it, but also we want to make sure that there's no insect activity going on the walls. I've even seen lizards run up the wall and leave excreta. So it's really important that we keep the walls clean and on the cleaning schedule. I know we put it on there sometimes and it doesn't actually get accomplished, but frequent cleaning and painting will keep that surface free of any potential contamination. Again, it is a vector as opposed to a food contact surface. So how many times do we bump into the wall or touch the wall as we're moving through the plant and bring any contaminants thereon into other areas where they shouldn't be? Even more critical than the walls are the doors, because as you know, they get frequent contact. And anytime you're seeing those smudges on the doorway as well as on the door handles or door plates, you know that the cleaning program just is not effective. Those smudges are going to happen and they need to be a very integral part of the cleaning procedures. Garbage receptacles are typically very well maintained because everyone just recognizes that as a potential area for contamination. Raw material storage areas, again, because of the food contact, we want to make sure they're clean, organized, free of damage and spills. That the raw material area and the finished goods storage. Free of damage and spills is another emphasis point, because what we're trying to do in a food manufacturing facility is ensure that there is no attraction for pests. So be that rodents or insects crawling or flying. If we have our ingredients exposed, then quite naturally that's going to be an attractant and a potential harborage area. How long that takes? Not long. Not long at all. You think about the straight flies or gnats or even storage insects that may incidentally enter our facility, which would be caught by our pest control program unless we provide a more attractive area for them to hide out and breed and live in, like our ingredient products. With just-in-time ingredient management, we try not to keep ingredients in the facility for any longer than necessary, but just because of ordering patterns, there's always that ingredient that could sit around for 3 to 6 months, maybe even longer, wherein we might not notice that it has become a potential source of pest harborage, or at least pest attractant into the facility that will spread onto the rest of the ingredients. And finally, the chemical storage area, because the cleaning chemicals, again, are being brought out into the manufacturing environment when we get into cleaning, We want to make sure they're organized so that we can access them accurately, free of damage and spill, so that they're not a source of contamination. As the cleaning crew or the operations team members are going in and pulling or utilizing those liquids for whatever they need around the plant. It's very easy for that to get onto your clothes, onto your shoes, and track throughout. Our final areas are the employee office and maintenance. Again, this is where we're trying to get to that last and most important vector, which is ourselves. So we want to make sure the areas that we work in or our office teams work in are clean and good repair, free of debris and buildup, so that we're not a source of contamination as we move in and out of the production area or storage areas for whatever reason. Same thing with the walls, floors, ceilings, any overhead pipes and doors. We want them to be in good repair and free of cobwebs, leaks, and stains, as well as condensation and, again, buildup. One of the key areas I want to mention about the office area is computers and keyboards, mice, or any type of equipment or things that we handle on a regular basis, chairs, because again, this is what conveys, our hands are the primary vectors for conveying microorganisms, so we want to have those on a regular routine cleaning schedule. Exterior and grounds are also a good attractant for, it's our first vein of attraction for pests, so we want to make sure that they are clean and in good repair. Any drainage prevents standing water or stagnant water from harboring or breeding insects and bacteria. Doors sealed and locked, just so that we control the flow of traffic in and out of the facility. Grounds are free of weeds, pests, harborage, and debris. For the same reasons as mentioned above, we want to make sure that there's not an attractant or harborage area for pests. Equipment is stored away from the building or organized for inspection. That's another place where we might get rodents or insects to breed, and especially garbage receptacles. Our dumpster area, recycling, all of that needs to be, first of all, cleaned on a regular basis, and second of all, covered, so that birds aren't attracted to not only feed, but then to leave droppings, as they all do. And finally, plumbing. We're looking for it to be sealed or at least screened, so that pests that are on the outside of the facility stay there and don't enter in through our plumbing. Any holes or in the structure of the building that allow pipes to enter, we want to make sure they're sealed, because they are a good transport valve for rodents and insects. They feel the warmth, they are attracted to the water, and they do what we call chase pipes from the outside and into the facility. So we want those sealed on the outside as well as sealed on the inside. And we talked about the walls of the external walls of the facility being clean and in good repair, as well as the grounds being free of weeds, pest harborage, and debris. A really critical area is our dock, because of all the truck traffic and the potential for product spills and the attraction of birds and other pests to that area. This needs to be on a more frequent cleaning schedule, potentially, than other areas of the plant. Another area I want to mention is if there's external picnic or eating areas. That's another area where we could potentially have food that may be left around or wrappers that might attract pests. So again, keeping our cleaning schedule up to date so that it's effective may mean having a different schedule for different areas of the outside. So keep that in mind when you're doing your sanitation program or your cleaning program. Housekeeping is another name for it. Here's a picture of a good-looking dumpster area, nice and clean and covered. Whenever they come to pick up the dumpster, the pad underneath is cleaned and repaired. And this is what we want our area to look like, such that it doesn't attract pests. Our warehouse area should be free of pallet splinters, food spills, mud tracks from the potentially wet processing area and out into the warehouse or refrigeration, cooling, whatever type of product storage area that we have. I see a lot of facilities that will have forklifts tracking water throughout the facility with a lot of dirt and potentially bacteria in it. We want to keep the ceilings clean, especially in the warehouse area. A lot of times, the ceilings as well as second layers of pallets and storage will drop debris down onto the top of ingredient and product, which then we know goes directly into the manufacturing area to be a source of contamination. So cleaning from the top down and making sure that there's not cobwebs, leak stains, debris will keep our food ingredient integrity intact. Overhead pipes being a part of the ceiling. You know, you often get that buildup of dust and debris on the top of the pipes. Well, we know that if there's buildup here on top of the pipes, then the rest of that buildup went through the pipes and onto the surface of something. So let's keep in mind air quality handling systems as well. We won't talk about those in detail. That's probably a topic for another presentation. But those should be maintained, as we mentioned earlier, in the best condition to prevent contamination of surfaces from debris in the air. Doors. Can't emphasize enough the amount of activity. You know, most doors, they don't look this good. Any type of bumpers and plates or views, windows, usually full of handprints and buildup. Again, we want to prevent that because that indicates contact, which eventually transfers to our product. So how do we get there? Our most important asset is our chemicals. And what does the Code of Federal Regulations say about chemicals? It says cleaning compounds, sanitizing agents, processing aids, and other chemicals used by an establishment must be safe and effective under the conditions of use. So safe meaning they are the proper chemicals, and effective meaning they work. They do the job. Such chemicals must be used, handled, and stored in a manner that will not adulterate product or create unsanitary conditions. So that goes to keeping the area clean and free of spills that would adulterate the product or create unsanitary conditions. And finally, documentation substantiating the safety of a chemical's use in a food processing environment must be available to FSIS inspection program employees for review, and you can substitute there any type of inspector or auditor that you will have in your facility. FSIS would apply to primarily the meat industry. So what does this documentation look like? Material safety data sheets, as well as your cleaning procedures. The two should match up. So there really should be your cleaning chemicals. Anything you see in the storage area should have a material safety data sheet. It should be on a list of approved chemicals, which should correspond to your procedures. The types of chemical dispensing methods that are often used in manufacturing are either manual or automated. So manual meaning that you would have a scoop or a cup or some type of a pump dispenser, and you'd have to mix the chemicals yourself. That requires daily concentration verification to ensure that we're not exceeding the concentration levels that are deemed safe in the environment being used. And this method tends to be more susceptible to human error because each time there's a potential that it won't be done properly. Training is very critical. Compliance to the training is very critical. On the other hand, we have the automated systems where we only need to calibrate monthly because they are predefined or calibrated to deliver the same quantities each and every time. But it's more difficult to detect errors because we would assume that they're correct and we're not revising the system. We could go on for long periods of time without knowing that our delivery systems are inaccurate. So again, we want to make sure that they're checked and calibrated monthly. Types of cleaning methods that we want to incorporate into our program could be clean in place for equipment that we cannot move or disassemble. A lot of closed systems will utilize this type of method, specifically the dairy industry or sauce packets, where they will flush cleaning chemicals through the lines in order to achieve sanitation. Time, temperature, and pressure are critical in these systems and have to be measured and monitored at all times and recorded in our documentation. Clean out of place means we would partially disassemble equipment like collars and gaskets and any type of tubing that we could submerge into a sink or put through a washing system. And we often do have some separate pressure tanks that are used to clean these items. And then finally, we have manual cleaning, which involves total disassembly of the equipment and individual part cleaning. So each one of our procedures needs to specify what type of disassembly, and if there isn't disassembly, what type of time, temperature, and pressure needs to be involved in order to ensure an effective clean and sanitation. How we implement the system could vary between internally managed versus external. Internal would involve company employees who are familiar with the operations, so they would know where the hang-up spots are, and they would also be responsible, or we would be responsible for our own training in that event, or an external company which would have its own third-party employees, or perhaps they train our employees. But they would have focused expertise on the chemicals and types of substrates to be removed, and would typically provide documentation on the chemicals and procedures being used. So that's just a decision, that the company will have to make in terms of what their resource levels and expertise needs and availability are, whether or not you go with an internal versus an external chemical company. But keep in mind, again, the company is ultimately responsible and needs to review not only the performance of an external company, same as they would their own employees, but also needs to review and ensure the documentation is accurate and applicable to that environment. Sometimes they do a generic manual and it will have procedures in it that don't actually apply to your operation, and again indicates that there's not really correct and accurate documentation of the systems, that it's just paperwork that's been generated and not being used. So we don't want that to be the case. So an annual review with the company to ensure everything is up to date, or as often as changes are made. Sometimes they will contract with a new chemical company. I see this more often than anything, and change out all the chemical names, and they won't match up to what's in storage, may or may not match up to the MSDS, and definitely won't match up to the procedures. So when we talk chemical safety, what we wanted to get down to is these tables I wanted to just put in your possession for your access. So as you're developing your program, you have a guide, especially if you're not going with an experienced third-party chemical provider and you're developing your own programs. You need this guide to know what types of cleaners you need to use to, again, be effective and make the job easier. If you're using the wrong cleaner, it's going to be slow, difficult, and possibly never work. So sugars, starches, salts, the solvent or what dissolves them and allows them to be carried away off the surface of your equipment or facility, floors, walls, etc., is just warm water. Emphasis on warm. Heat or warmth of the water always makes that dissolving property. If you've had or done any chemistry, you know heating up the water and adding that energy makes the water more active and able to dissolve the various substrates. If you've got a starch, a more complex starch, you want to add a mild detergent to that. That's going to add to the adherence properties and allow that starch to be removed. If it's a starch and protein, you want that detergent to be highly alkaline with a high pH. For chemical reasons, it binds better and it removes the protein better. Mineral deposits often require an acid. Sequestering agents, phosphates, or chelating agents are usually added to that to make it more effective. Again, we're here creating a whole chemical interaction in order to remove these really stubborn, because putting two metals together, they tend to form a physical bond that are just water, detergents, and even scrubbing will not remove, as you know from not only your plant environment but your home. If you've got mineral deposits build up on your faucets and tubs and sinks, it's really difficult to remove that with just an ordinary cleaning agent. Again, another mineral, limestone, would require an acid. Proteins, again, we talked about alkali or alkaline detergents. Sometimes hypochlorite and a wetting agent are added. This, for some reason, helps to liberate that protein from the surface. Fat emulsion, again, can be dissolved in water, but we want to heat that water up, again, to melt the fat. We will add an alkali detergent sometimes because that will help to lift that fat away from the surface so that the water can carry it away. Then we've got lubricating greases and oils will be pretty much the same environment. We'll need hot water, even up to steam. And sometimes we'll add a surfactant, again, to lift and move that fat away from the surface, or grease and oil. When we get biofilms that we talked about earlier, where bacteria have begun to or will grow underneath a layer of buildup that hasn't been removed, we may need to add an oxidizing cleaner as well as a sanitizer, again, to kill the bacteria. The most difficult is probably charred or carbonized materials, where we need an organic solvent. So going through your chemical list, you'll want to make sure that you have approved something on this order if you have these types of ingredients within your facility, so that your team can always have a solution and a procedure for removing buildup. Definition of some of the additives that go into the cleaning chemicals. We talked about having a sequestering agent, which is the same as a chelating agent. Examples of this that you'll see on the labels of the chemicals that you'll procure will be tripolyphosphate, tetrapotassium pyrophosphate, organophosphates, and polyelectrolytes. So don't be intimidated or ignore these names. Know that these are your friends. You want these to be added to your chemicals to make them more effective at binding and removing some of the substrates that you encounter in your process. know that we're running short on time, so I'm going to get through this very quickly. Chelating agents, again, form compounds or complexes with the ions, metal ions that are left behind by our hard water, and they actually produce a precipitator scale. And we want to make sure we have, again, the right combination of ingredients to act on the substrates that are in our environment. Additional additives include oxidizing agents, enzymes, and fillers. Oxidizing agents and enzymes are active and will actually, again, bind to substrates and help to remove them from the surface. And then fillers are just bulking agents that allow us to spread a small amount of chemical across a large surface. Choosing the best sanitizer that's best in a variety of environments is usually where you want to go, because knowing exactly what type of bacteria you're dealing with is unlikely. Unless you've done a swab test and found out that you've got a particular bacteria that you're fighting and you need to go with the chlorine or iodophor or clot cleaner, then you just want to choose one that's generally good for everything and specify if you have a problem. Again, here's a table that kind of goes through the different types of cleaning chemicals: steam, chlorine, iodophores or iodine, quaternary ammonium, and then acids. So it kind of tells you what you're going to get into and what you're going to be dealing with. The best penetrant is acid. The most corrosive is chlorine. Highest irritants are acid and chlorine. So you just want to know if what you're looking to as a chemical is going to be a potential risk and needs to have protective gear involved or protective information conveyed to your employees on how to protect their safety. Whether it's stable in hot water, that's important if you're using hot water as a cleaner. Whether it leaves a residue, has any flavor or odor impact like chlorines and iodine. Steam, of course, is very difficult. They say it's poor because it's very expensive to generate steam with having to use utilities to create it, and then it's gone. Ease of use, of course, foams, because they stay on the surface for a while. And let's see, if there is a maximum concentration that we talked about earlier, it needs to be employed. That needs to be tested on a regular basis and confirmed, because it could be a potential chemical contamination. Whether it's expensive or not will affect your bottom line, so you'll make some decisions based on that. And finally, where it's approved for use, it is important to keep in your approved chemicals list, so that any employee referencing that product, you have a liability control there. And this is just a little additional information with regard to concentration that you can review if any of these chemicals tend to be in your arsenal. More detail on each chemical, specifically chlorine, because it tends to be the most used in the food industry. It's effective at low temperatures, which is good. It keeps your energy costs low. It's inexpensive, leaves minimal residue. It is corrosive, especially at high temperatures, so you will get, especially on your stainless steel equipment, you can get a lot of rust or corrosion. It's irritating to the skin, so you want to make sure you're always using gloves and protective gear. It can be deadly when the pH drops, so you don't want to mix it with other chemicals. It can even create mustard gas, which is highly, highly toxic. and under some conditions forms potentially carcinogenic trihalomethanes. So chlorine is not to be played with. I mean, we use it quite often and extensively, but we do need to keep in mind that it is a dangerous chemical and needs to be used in the proper manner. And then this just gets into the chemistry of how it works, how it breaks down into the different types of substances that bind to the materials we're removing. Here's a time temperature chart for your COP cleaning tank. So if you're doing the COP operation where you partially disassemble some of the equipment, if you're going to use moderate temperature water, you need to leave it in there for 30 seconds. If you have control over the temperature and are able to optimize it, then you can do a single dip and move the process along more quickly. Using iodine, a lot of times facilities will rotate the types of cleaning chemicals so as not to create resistant bacteria. And so there's some information here about iodine. I'm not going to get into this in too much detail because it is a pretty infrequently used. A lot of times it's used for hand dips, but not so often used in a chemical sanitation program. Mostly because it does leave an unattractive orange-brown stain on plastics, which makes them look like they are unclean. It's not very cheap either. And it's very dependent on temperature. So if your water gets low in temp, it is less effective. And if your water has a lot of mineral deposits, it's a lot less effective. It's toxic, but very, very effective on bacteria. So in the event that you have some stubborn or resistant bacteria, you may need to go that route, at least temporarily, to get rid of some of those buildups. Acid is even more corrosive and requires much more control and safety than even iodines, but is the most effective. So again, you want to make sure that if you have a stubborn situation and need to use that you take all required precautions. This is more detail about additional cleaning chemical and sanitation chemical options. Peroxide, we didn't even spend too much time on this, but because we don't use it very much in the food manufacturing industry, but it is also an effective sanitizer as well as cleaner. Perioxyacetic acid is probably the most often used acid, especially in the produce industry. It's also moving into the meat industry. So we have some of the usage elements here for your reference. It does have a pungent odor. We talked about quarks, and this is talking about how they actually interact with the bacteria to break up the cell membrane and kill. But keep in mind that a lot of people will have reaction skin sensitivities to quaternary ammonium. So they should not really be used as like a non-glove hand dip. And finally, chemical safety. In the storage area, chemicals need to be kept in a secured area with proper labeling, including the name, date, or expiration date and manufacturer. Spill containment. such as the spill containment pallets needs to be employed, and have a eye wash or shower nearby in case there is a spill or a splash for employee safety. Any other protective gear like rubber shoe covers, an eye wash bottle, a face shield if necessary, especially if you're using the acid or one of the more corrosive or toxic chemicals. Gloves at all times, because there's pretty much nothing that's going to kill bacteria that's not going to eventually be, harmful to your skin over a long period of use. Goggles, again, to protect your eyes. We don't want any of what we've mentioned today in our eyes. And again, an apron just to protect your clothing. Some of these chemicals can be corrosive to your clothing as well. You all know the effect of bleach or chlorine on your clothing. Sometimes facilities will have a dispensing system in the production area. That would be considered unsecured because anyone could remove this, remove the tubing, take the bottle out, and dump that into product and contaminate. And whereas we would think most employees or team members would not want to do that, you may have a disgruntled employee who may take that idea on. In this area, while it is secured in a separate room, it's a little disorganized. We don't want anyone to trip. Again, we've got dangerous chemicals here, and we want to keep employee safety in mind at all times. So we want it to be organized so that we can not only find what we need and use what we're supposed to use, but also so that we don't get harmed in the process. The Code of Federal Regulations requires that the regulatory agencies such as USDA and FDA have control through the EPA over these chemicals. So they will be defined in terms of their use, and we need to adhere to those determinations. Again, chemical safety and security, they should be monitored or secured at all times. That means in the sight of the accountable and trained personnel, never stored with product. If they're accessible, they should be diluted to those approved concentrations that we noted, or they should be locked away in a cabinet or room with restricted access only to those personnel who are approved to use them and have been trained as such. Employee training should involve safety and usage as we've gone over today. So this webinar actually constitutes your training for chemical and sanitation training. You'll need additional training to your specific job responsibilities, but you are now knowledgeable about chemical safety and cleaning and sanitation. Just as a brief review, each surface in the facility has a defined level of cleaning required, be that cleaning or sanitation. Direct food contact surfaces must be sanitized such that microorganisms or bacteria are reduced by 99.99%. 5 steps for effective cleaning are removing debris, applying cleaning chemicals, scrub surfaces, rinse, and then apply sanitizer. Very critical. Chemicals which are not acceptable for food contact solution must be secured or monitored at all times. Here is a copy of your training acknowledgement. You can take this form, add your company name, write your names here, your title, and sign here, and that is your documentation that you have received this appropriate training for chemical safety and cleaning as you get audited and are asked about this training. And then as an assessment that you have absorbed and are understanding this material, here's a true-false quiz with answers on the following page. So don't look at the answers until you've done the quiz. Here's references where you can get additional information about the topics that we've discussed. It is my source of information. I always try to make sure that I go to the sources. And at this time, I would like to thank you all for your patience and your time and open the floor for questions. I'm going to turn it back over to Michael for his facilitation of those questions.
Great. Thank you so much, Melinda. Thank you for your presentation. Ladies and gentlemen, like Melinda just said, we'll open the floor for the question session. So if you do have any questions, ladies and gentlemen, what you could do is for any verbal question which you would directly like to put forward to Melinda, what you could do is you could click on the raise hand option, which is a palm-like icon at the bottom of your participant screen to ask your questions verbally. Or you could also post your questions in the Q&A panel so that Melinda can read that out loud and then answer. Or for any reason, if you're unable to ask your question using either of the two means, you could always share it with me by chat, and I shall pass it on to Melinda to get you an answer. So if you do have any questions, ladies and gentlemen, please do go ahead. And while we just wait for any questions to come up, I also want to inform our participants that the feedback form is open in the polling panel right now. So we would really appreciate if you could share your feedback on today's session. There are just over 8 questions, and they're all multiple choice in nature, so it shouldn't take you more than 2 minutes to share with you as to how the event went on today. So we would really appreciate your feedback. And ladies and gentlemen, we have a few minutes, so if you have any questions which you could think of, please do go ahead. And also, ladies and gentlemen, if you can't think of any questions during today's session, you could always send me an email with your questions, or you could always write into GlobalCompliancePanel.com, and we shall pass on the questions to Melinda to get you an answer. Melinda, I don't see any questions coming up. We'll just give it an extra minute to see if any questions do come up.
Sure.
Thank you. And while we wait for that, once again, ladies and gentlemen, on the screen you could see that this webinar is available for purchase on a recorded version. So if you are interested, or if any of your colleagues or friends are interested in today's topic, you could always give us a call, or you could always check it on our website online as well. And there are a few other webinars mentioned on screen. These are, again, few of them. There are more on the web page. The links are in the presentation handouts. So if you are interested in any of Melinda's topics, you could always check the web page on the Global Compliance Panel page. And at the same time, you could also see a few of the upcoming webinars from Melinda Allen. These are, again, a few of them over the next couple of months. So if you are interested, you could always give us a call. Melinda, I do not see any questions coming up, so we shall go ahead and conclude today's session. Do you have any concluding remarks for today's audience?
Just a thank you for all of the participants, and that if you have additional topics that you are interested in, feel free to notify the Global Compliance Panel team. And if I don't have expertise or knowledge or information in that area, I'm hoping that myself or one of my colleagues can get that information for you and provide any training for your needs. Thank you so much.
Thank you, Melinda. Melinda, before I let you go, I in fact got a question on the screen right now. There's a question in the Q&A panel. I'll just read the question out to you. It says, the question says, is it mandatory to use a detergent for cleaning? Can cleaning be done using hot water and a sanitizer?
It absolutely can. As we mentioned, there are some substrates or food ingredients that don't require a detergent, and you can absolutely just use warm to hot water or even steam, and it can be an effective cleaner in certain environments. It's not mandatory to have a detergent.
Thank you so much, Melinda. Ladies and gentlemen, again, Melinda, I have a few other questions as well. One more question on the screen which says, if cleaning validation is in place, is it required to do ATP testing before production?
That is dependent on your client or your customer, but no, it's not required on a regular basis by Code of Federal Regulations. If you have that validation on file, that serves as, again, your validation. Sometimes you will have clients or schemes that want you to do it on a more regular basis, and again, that's an agreement between yourself and the customer.
Thank you, Melinda. I hope that answers the question. And ladies and gentlemen, we're just running out of time. So once again, like I told you earlier, if you come up with any questions after today's session, you could always write in to us. On screen, you could see the numbers as well, or you can send me an email directly, and I'll pass it on to Melinda to get you an answer. Now, ladies and gentlemen, I just want to go ahead and conclude today's session. And once again, just want to keep you updated that the polling panel is open with the feedback form, so would really appreciate it if you could just take a few minutes of your time. This is again just to ensure that we can keep up our standards in conducting our webinars. This applies again to the Global Compliance Panel team and Melinda Allen as well. So we really appreciate your feedback on today's session. And once again, ladies and gentlemen, I want to thank you all, and on behalf of Melinda Allen and the entire Global Compliance Panel team, thank you all for attending today's session, and do wish you all a lovely evening ahead. Thank you so much. Melinda, thank you so much.
Oh, you're very welcome.